Okay, here we've got the skill graph sinusoidal functions phase shift. And this really puts together all the different modifications that we can make to the basic sinusoidal functions here. Now, the basic sinusoidal function here is cosine, and we're just supposed to take our knowledge of the basic cosine function and our notions of shifting, shifts and stretches and compressions, and apply it to this so that we can then graph the cosine function. Now, I always recommend a great tool to really, you should be able to do this on paper without having to graph it. Eventually, you'll get good enough at it. But as you are practicing it and just learning the skill, it's really helpful to actually have kind of a graphing calculator like Desmos. This is a free calculator available to anybody online. And you can just see what each of the individual modifications do. So the first thing that we want to do, this is our basic cosine function, right? This is the function that we're modifying one way or the other, okay? The first modification is that we subtract 4 pi from the inside. And let's see what happens to the graph. And the answer is absolutely nothing, okay? I mean, something really did happen, but what happened is everything gets moved to the right by 4 pi. But really, the cumulative effect is nothing because we're moving it a multiple of 2 of its periods. So at this point, if you think of the cosine, if I was able to grab this curve and I was able to move it over to here, the resulting curve wouldn't look any different than the original because all the waves of the cosine graph sit on top of each other perfectly, okay? So if I move it over 2 pi, which is the cosine's period, it sits on itself perfectly. If I move it over another 2 pi, it again sits on itself perfectly. So even though we did move the whole graph to the positive direction, it doesn't really look any different because the cosine graph's infinite. Okay, now what would happen if we multiplied the x on the inside by pi? This is what we call a stretch. Okay, a horizontal stretch. It actually, in this case, is going to be a compression. It's the opposite of a stretch. It doesn't pull it wider. It compresses it in because this is bigger than 1. So if we multiply x by pi, what happens is it's going to compress the period. And we see that happen, right? So now, in the original cosine function, the period is 2 pi. Let's see, yeah, 2 pi. Now the period is just 2, okay? That's because we take 2 pi and we divide it by pi to get the resulting period, okay? Now let's multiply the outside by 3 and see what happens. This is what we call a vertical stretch or compression. If we multiply by 3, this actually stretches the graph out. You see how up until this point, even though we changed the period, we didn't change the amplitude or the midline of the function, okay? What this is going to do is it's going to change the amplitude, and the waves and troughs are going to get a lot bigger, okay? So you see, now we have this red function, right? The period is the same as the previous one. Nothing's changed with the period. It's still 2, okay? But this time the waves get a lot higher. Okay. Now all that's left is what happens when we add this 2 on at the end. And this is actually going to be a vertical shift. This is going to move everything up by 2. Okay. So it took this red graph and it just pushed it up by 2. Okay. So where this point is at a height of 3, right? This is going to be at a height of 5. Okay. Really what it did is it moved the midline from 0 up to 3. Now 3 is going to be the midline of 2 is going to be the midline of the function. So I hope that helps a little bit on this. Desmos is tremendously helpful at making sense of these graph shifts, especially if you apply them one by one. You can really see what each one does.